Hello everyone and welcome to our next video on Simple AI with Python and Colab. And today we take a look at the extremely intricate subject of human speech. How do we humans speak? Can we make computers utter human words? And we'll do today a very simple thing. We'll try to make computers say ah and oh. These are two vowels and we will try to make computer create the sounds completely mathematically. We'll need a few libraries. It will be Pyplot to draw sound waves, IPython display to have audio controlled, librosa to extract sound wave, and NumPy will be our hero of today. It comprises a very specific function we will use. So I've recorded an audio file with my ah and oh, and we will cut out 10,000 timestamps fragment from it. Let's listen. That's me, I am not a robot. And then we will try to rebuild these completely mathematically. We have the same 10,000 timestamps timeline, and we will try to dissect original wave and analyze it and rebuild it from scratch. And the thing to do it will be Fourier transformation. What is it? You know that any sound wave can be represented as a superposition of sinusoids, periodical functions. And the thing to do it is Fourier transform. We can first extract spectrum, which is frequency versus amplitude, and then for each of the frequencies we can build a periodical function made of cosinus and sinus. Just don't get deep into the formula, believe me, and we sum them all up. It will be around 70 of them, and it will be something like original wave. And we will plot spectrum and the final wave and listen to it. Let's do it. So you see, this is a spectrum. From the start there are very high amplitude frequencies and all the others are small amplitude, and there is a fragment of final audio wave. Let's listen. Well, it's a little bit robotic, but it sounds like R. Let's do the same with O. Also robotic, but sounds like O. So what are the roles of these frequencies and periodical functions? You see that there are spikes, very huge amplitude from the beginning, and it's not what makes A or O or U or E. It's just a pitch or tone, because I can say there is no vowel, it's just a tone. It gives us this general pattern of undulating, and all the R and O distinctions are made with those smaller vibrations, with all the high frequencies. And the further we go to the high frequencies, closer we get to this breathing of humans, and it paints the sound into human-like features. And if we compare R versus O, you will see that they are very much similar, only the R sound is a little bit more complicated. It has many notches on the eastern slope, while O has very steep, straightforward slopes. And bottom side is tooth-like things, and here with R we have just spikes. Okay, so that's how we can make computers speak. It's how we can create artificial voices. You just play around waveforms and frequencies and periodical functions and superpositions, and this is the magic nature of the sound and hearing. It always astonishes me, because even the most complicated song with all the musical instruments and voices and words and lyrics, it's all just one line. That's magic. So thanks for being with me today. Subscribe to the channel, subscribe to simpleai.net. See you, bye.